Greetings, everybody. So here is another problem that I've taken from MyMathLab to show you, and it's another problem that's what we would call an optimization problem. So an optimization problem is one where, no matter what the situation is as it's presented in the question, it's asking to maximize or minimize something. So here we're going to build a fence under certain specifications, and it says to find the cost of the least expensive fence. So that's like minimizing the cost. Okay, the area's got to be a certain size. Okay, and the cost of materials are also fixed to be certain dollars, right? And with those fixed constraints, we want the least expensive fence. Okay, there's lots of ways you could build a fence that is what is that, 5,000 square feet. Okay, lots of ways to do it, but there's only one way that will minimize the cost. Okay, so what I did was I started with a drawing because I think it makes it easy for me to explain things, and I drew a rectangular area. That's what it says we're trying to fence, and it's got a width and a length. Okay, so two widths here and here, and two lengths here and here. Okay, and it says that the material costs $2 per foot for the two sides facing north and south. So I drew a little compass here to say, like, okay, well, this side's facing north and this side's facing south. So those two sides, the fencing used to construct them is $2 per foot. Okay, and then we get, the cost is $4 per foot for the other two sides. So like this side here, the cost of materials is $4 per foot. Okay, okay, that's what we got. Here's my picture. Now I put that there to present all the information to you. We could read the question and we can see what all the information is, or I could summarize what all the information is in this picture. Okay, so, well, we want to minimize the cost of the fence. I need a formula that will calculate the cost of the fence. Okay, given that at this point I don't know what the width and the length are. Okay, I just got W for the width, L for the length. So here's the formula that I present to you for the cost of the fence. Let me explain it. You see how I said this side, the cost of materials is $2 per foot. Okay, so how do I calculate the cost of that entire side? It has well, think about it like this. If the material costs $2 per foot, and suppose this was 3 feet. Suppose that side were 3 feet. How much would it cost? 2 feet, 2 feet, it costs 6 feet, right? $2 per foot, 3 feet, that makes $6, okay? So what you would do in general is take the cost per foot times the length in feet to get the total cost. So what I have here is 2W. 2W means $2 per foot times W, the length in feet, gives you the cost of that side. Then I have another 2W. What's that going to be? It's going to be the cost of this other side that has a length of W, and it's $2 per foot. Then I got 4L. Okay, why is that? Well, this side here is $4 per foot and has a length of L. 4 times L is the total cost of that side. And then I have another 4L. That's the total cost of this side, $4 per foot with a length of L. So there's your total cost, and we can combine some of that. I got 2W and another 2W, that makes 4W, and 4L and 4L, that makes 8L. So that's what I'm working on minimizing. Now, always in our class, we deal with functions that have only one unknown or one variable in them. This function has two unknowns in it, okay, W and L. So what we will always need to do is eliminate one of those variables, okay? So how can we do that? Well, when I got this equation, did I use all the information that was given? I mean, it makes sense that, it's not a guarantee, but it makes sense that you would need to use all the information. So I didn't use anything about the area needing to be 5,000 square feet. Okay, so what I do is this. The area must be 5,000 square feet. What's that mean? Well, the area of a rectangle is the width times the length. Okay, so that means that the width times the length, or W times L, must be 5,000. I could solve this for either W or L, and then I could make a substitution and get rid of one of these variables. So look, I solve for L, okay, and then I take that and I put it up here for L, okay, and then I get to reduce this function that I'm working with to be only a function of one variable, W. All right, so see, what do I get? For the cost is 4W plus 8L, which I found to be also 5,000 over W. Okay. Now what I do next is this. I can find the minimum value of a function or the maximum value, whatever, depending on what I'm looking for, if I solve its derivative equal to 0. Okay. So what I decided to do was this. So that I could use the rules for derivatives a little bit easier, I multiplied the 8 and the 5,000 because I can do that. You know, it's 40,000. All right. In this W that's under the bar there in the denominator, for the sake of using the rules for derivatives, I wrote that as W to the minus 1 power. Okay. Now that's the function right there that gives you the total cost of the fence. And I'm going to take its derivative and set it equal to 0. All right. So okay, that's our general procedure. We minimize or maximize something. We get a formula for whatever that something is. We find its derivative. We set it equal to 0. Solve it. That's how we solve optimization problems, if I could put it very briefly. All right. So let's see. What's the derivative of 4W plus 40,000 times W to the minus 1 power? It would be 4. And the derivative of W to the minus 1 power, I'd bring that minus 1 down to the front, giving me negative 40,000. I would subtract 1, and it would give me negative 2. So there's your derivative. And like me, what I'm going to do, because I have to solve this equal to 0, I think it'd be a little easier to solve if I now put this W to the minus 2 power back under the bar and make it W to the positive 2 power. Okay. All right. So that's the derivative as I'm going to solve it equal to 0. So here's the setup for that. How I solve it goes like this. I move this to the right, giving me 4 equals 40,000 over W squared. Here I multiply both sides by W squared. I get 4W squared equals 40,000. I divide by 4. I get W squared is 10,000. And what did I do in this last step right here to here? I took the square root of that number on the other side. I didn't write that step, but you know, W equals root of 10,000. And that's 100. 100 what? 100 feet, right? Because W was the width of that rectangle in feet. Okay, so 100 feet. All right, now sometimes, like when we go through the procedure for solving a problem, and we get an answer at some point, right? Here it is. W equals 100 feet. That's definitely an answer. I guess the question is it the answer we're looking for? Okay, so we're going to find, you want to minimize the cost. And basically what I found is if the width is 100 feet, then that's the way that you'll need to build it to minimize the cost. Okay. But it's asking me, what is that minimum cost? The cost of the least expensive fence is what? Okay. So when I solve this initially, it's like, you know, 100 is not the answer that I'm looking for. I'm looking for the cost. Okay. But this will take me there. This is the width that gives you the minimum cost. So what I can do is I've got all these formulas, and I could find one that gives me the cost of the fence. Like this one does that, and so does this one, and so does this one, and so does this one. See, every time you see that C there, right there, that's a formula that gives you the cost of the fence. Okay, so I could use any of those, put in W, and try to get that number. Now, I think the one that, you know, is easiest to use is you know, this one right here. So that's the one that I'll use. I will put my solved value for W, which is 100, in for W. So I get 4 times 100 plus, 4W plus 40,000 times W to the minus 1. Okay, W is supposed to be 100, so put 4 times 100 plus, and for the sake of calculation, I did 40,000 divided by W, which is 100. And I can use my calculator at this point if I want to, and that turns out to be 800. 800 what? 800 feet? No, $800. The cost is in dollars, okay? There, and that's my answer, right? Here, up here, what is it? The cost of the least expensive fence is $800. Okay, so that's the whole procedure. Now, I give this disclaimer in every video I make of this type. Yeah, I gave more detail than you might want, or when you solve this, you might skip some steps and so on. And of course, like once you see how I solved it, you might skip right to this step, incorporating the costs in. Or when you get the cost function, you might get straight to the derivative and so on. So sure, I might give you more explanation than you need, but I just want to give you enough that you can take away whatever it is you need to apply to the problem that you see on MyMathLab and solve it successfully. If there's something here, if I skip too many steps on the other hand, then you can always contact me and I'd be happy to clear it up.